Hello everyone, welcome to the question show on my YouTube channel. My questions, wait, your questions, no, my answers? Anyway, once a week, I take all of your questions live and prepared and gather them up and answer them in real time. I do this show every Monday at 5 p.m. Pacific time. So if you want to join live and join the conversation, ask your questions, that's your best shot. But also, just ask a question anywhere across my channel and I will gather a bunch of them up and I will answer them here. So we are recording this episode on Monday, April 12th. 2021, and this is of course 2 days before the Ingenuity helicopter is expected to fly. So I'm sure once again Chad's going to put up a little picture of what happened. Come on, don't crash is all I'm asking. All right, let's get into the questions. Alberto DC: could we use the heat of Venus's atmosphere to power a rover? Unfortunately, we can't use the heat on Venus to power the rover. Heat is great. If you have a lot of heat, that's perfectly fine. There's a lot of ways of generating electricity if you have a lot of heat. And I'll give you a great example. Curiosity, Perseverance, the Voyagers, New Horizons, they're all powered by a nuclear RTG, which is a radioisotopic thermoelectric generator. And what that is a chunk of plutonium that is very hot, and it is slowly losing heat. And the heat is sort of moving from the reactor, or the chunk of plutonium, out into a cooling area. And there's a thing called a thermocouple, which is able to take advantage of a heat differential between two locations to be able to extract electricity. And so if you took plutonium and you just put it into a nuclear reactor, and you could get mountains, you could get kilowatts and kilowatts of energy out of that plutonium in your nuclear reactor. But in a RTG, in a battery, you only get a couple of kilowatts out of it. And so it's not a very efficient use of the energy, but it is long-lived. You can run this thing for 40 years, as we've seen with the Voyagers, and you get less and less energy over time as the plutonium decays. So why does that work, right? Why, if you have a chunk of really hot plutonium, but we can't get heat out of Venus's atmosphere? And the trick is that you need a temperature differential. And so if you're down at the surface of Venus, it's like 465 degrees Celsius no matter where you go. There's no difference in temperature, whether you're at the poles, whether you're at the equator, whether it's day, whether it's night, it's always that exact same temperature. And so you can't take advantage of this heat differential. In fact, the heat is the thing that's going to kill you, no matter what spacecraft we send down to the surface of Venus. I mean, the Venera program from the Soviets, it was murder on these rovers. They died within an hour because of this horrible temperature, this high pressure. And there's some new ideas that have come along that will try to sort of keep the heat outside of the rover for as long as possible. And one other super cool idea that I really like is the idea of a Stirling engine. You essentially have the inside of the rover cool down really cool, and as it goes down to the surface of the planet, you're essentially allowing the heat from the atmosphere of Venus to slowly make its way into the interior of the rover, and you're essentially powering an engine as you're doing this until the temperature inside the rover equalizes with the temperature outside the rover, and then you run out of energy. So you need a heat differential no matter where you're going to be able to take advantage of that high temperature. Steve Craw 314: what if the Mars helicopter tips over? Oh, let's hope it doesn't. I've been thinking about that. I mean, the helicopter is pretty big, but I think if it does tip over, I'm sure that the controllers operating Perseverance will attempt to right it with some part of Perseverance. I mean, it has a drill, it has kind of like an arm that it can use to sample rocks and things like that, and it has a microscope on the end of it. And so I wouldn't be surprised if they've already thought of ways that if the helicopter lands and then falls over, that it could go over and try to push it back up again. It depends on, I guess, how much damage the helicopter has experienced when it does fly. The first flight, the plan right now is they're just going to hover like maybe a meter off the surface of Mars, just test to make sure that it works, come back down gently. And remember, I mean, the gravity on Mars is 1/3 than what we experience here on Earth. And so even if you go 1 meter in the air, it's going to feel like you're much less than a meter. And if you fall from that height, you won't take as much damage. So, my guess, this is NASA. This is not SpaceX. They're going to test very carefully, step by step, to try to make sure that the helicopter can do what it's supposed to do, and they'll learn all of the parts. But I can imagine there's some gust of wind. It has some problem with one of its rotors while it's flying, and it falls on its side. And they'll debug the problem, and Perseverance will flip it back over, and they'll try again. So I'd be interested to see sort of how many times that actually does happen. The fuzzy kitties. How do modern spacecraft navigate in space? So right now, when spacecraft are flying through space, it really is a wonder of math and science. The fact that you can send a spacecraft at tens of thousands of kilometers per hour at a target that can be millions of kilometers away. Like, think about the journey that Cassini made from Earth all the way to Saturn, and arrive precisely where they expect it to arrive within a fairly small tolerance of issue. And so the question is, how do the spacecraft do this navigation? And right now, the answer is the spacecraft in general don't do any navigation at all. All the navigation is being done from Earth. And the way it's done is they have huge communication dishes here on Earth. And the dishes communicate with the spacecraft and are essentially tracking the location of the spacecraft. Spacecraft is communicating back. From those communications, they're able to determine the direction, how fast the spacecraft is moving. And they're able to see if the spacecraft is actually on target for where they're expecting it to go. The spacecraft has thrusters on board. And so if they need to make any kind of minor course correction, they can program in what kinds of course corrections it's going to need to make. And then it fires its thrusters and then is able to arrive. That said, NASA has been experimenting with other methods which allow spacecraft to navigate themselves autonomously. And so the one idea is this thing called a star tracker. So essentially you have a spacecraft that recognizes the star fields that are all around it. And it's able to then orient itself. It's able to determine what direction it's moving, how fast, and compare that to how fast it should be moving, and then make adjustments accordingly. Another idea that's being tested out, hasn't been implemented yet, like on an actual spacecraft, is to use pulsars. So pulsars are, of course, these dying neutron stars that are located around the Milky Way, and they are blasting out these signals that are incredibly precise, down to a tiny fraction of a second. And so you can tell when you're moving towards this pulsar or away from that pulsar because of the Doppler shift, sort of that same experience when an ambulance goes by and you hear the pitch change as the ambulance passes you by. And so you can imagine these spacecraft are essentially watching all these different pulsars, and they're detecting what their velocity is in relation to each one of these pulsars, and then they're using that to map their position across the Milky Way. And so you can, across the solar system. We're not in the Milky Way yet. And so you can imagine some future when every spacecraft is equipped with one of these pulsar navigation systems, and so it can essentially autonomously be able to find its way to wherever it needs to go across the solar system. Pretty cool. A.B. Scott and Flower. Do you think the workers at Boca Chica are being prepared to work in Luna or Mars? It's an interesting question, actually. It's a really good idea that if you're going to want to have people who are going to try to build facilities on the moon or Mars, it makes sense for them to start working at the Boca Chica facility so that SpaceX can just learn whether these people are prepared for space madness or not, but also to give them experience with all of the hardware that SpaceX is using. And you can imagine already the level of automation that's happening with spacecraft, even with, say, the Crew Dragon, is dramatically more automated. And you really are just the payload of these rockets. A ton of them are automated at this point. It's not like you can take control and fly directly if there's some problem. It's all done by computers at this point. And so the need for the people who are astronauts to also be test pilots is decreasing. And in fact, you're needing them to have other expertise, for them to be welders or 3D people who work with 3D printing assemblers and things like that. And so I can absolutely imagine a future where there's a sort of an apprenticeship where you come and work at the SpaceX facility first. learn all the hardware, all the technology, and then you start taking flights with Starship to go to the moon or Mars, probably the moon for starters, and help with building some of the infrastructure on the moon. It's a fascinating idea. And it's funny because we're just so used to the work in space being done by astronauts, by the best of the best, people with multiple advanced degrees. There's only like 500 people who've been to space at this point. And so suddenly there could be a team of construction workers sent to the moon to help build a landing pad. And they need to specialize in lunar concrete and deploying robots and setting up various machinery to harvest resources in situ. So yeah, I think you're right. I think you're onto something. Chris Sender, how would a James Webb Deep Field look different from the Hubble Deep Field? James Webb's main claim to fame is that it's going to be able to take the Hubble Deep Field and take it right really to the edge of the observable universe. So right now, Hubble, with their famous deep field where they pointed the telescope at a seemingly empty spot of the sky and gathered light for an enormous number of hours, they were able to turn up tons and tons of galaxies in what seemed like empty space. And then they came back later on and they did this thing called the ultra deep field. And they did a longer time frame, added more data, and they were able to get to the point where they were starting to see galaxies that were just a few 100 million years after the Big Bang, which is amazing. As well as some that were even better, things that were being gravitationally lensed by foreground galaxies. But they could just see just the barest hints of these first galaxies that were early on in the universe. James Webb will be able to go farther than that. James Webb will be able to look pretty much right out to the moment when the first galaxies were forming across the universe. And it'll be able to do it in any direction. So the kinds of either images that are seen by Hubble, thanks to gravitational lensing, where you've just got this perfect situation where you've got a foreground galaxy and a background galaxy, and Hubble is just barely able to see it. James Webb will just see these directly everywhere. And when they do their deep field, and they will, it will produce something very similar, but with far more clarity and far more galaxies. Because at this point, it's literally going to see every single galaxy that's forming in a region of the sky. So, it has 6 times the mirror size of Hubble, and it's in the right wavelength to be able to see the early universe. So when James Webb does its deep field, it's going to be an astonishing accomplishment. A $10 billion photograph. James T. Is the New Horizons team still considering another flyby? Yeah, I think they are always hoping for a new flyby. And, at this point, there is no plan for a flyby. There's no specific target that New Horizons is being targeted towards, but there's a bunch of new telescopes that are coming online. There's, of course, going to be the Vera Rubin Observatory, which is going to find all kinds of objects out in the Kuiper Belt. And that should be the machine that finds the next targets for New Horizons. They definitely have fuel remaining in their tanks, so they have enough propellant, assuming an object is within a nice enough cone in front of them, that they can do a few maneuvers and be able to put themselves on target to be able to go past another object. So we'll have to wait and see. But right now, there's no concrete plans for specifically what they're going to be going past next. More questions in a second, but first I'd like to thank our patrons: Joe Salinas, Phil Deshane, Michael Booth, Mike Driscoll, Anthony Davidson, and the rest of our 842 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Sean Marsden. Hey Fraser, it seems like the sample return mission to and from Mars is going to take longer than the proposed human to Mars mission. Isn't it easier to take a human with a microscope rather than wait? No, it's not easier to take a human with a microscope and return them safely back to Earth than to do a Mars sample return mission at this point. A Mars sample return mission, you've already got Perseverance, which is gathering samples. The Europeans have already built their rover, which is going to gather additional samples. The Europeans are going to create the return vehicle. The Americans are going to be producing the ascent vehicle. The Europeans are going to create the chase rover. And so you're looking at a few $1 billion to be able to put together the hardware to be able to return a pile of samples from the surface of Mars back to Earth. like maybe you're looking at another $4 or $5 billion. Compare that to sending humans to Mars and bringing them safely back to Earth. I mean, yeah, maybe, and maybe this video will age really poorly, and Elon Musk in 2022, so next year, Starship will be flying. It'll be re-entering through the atmosphere. They'll load it up with a bunch of scientists. They'll go to Mars. They'll set up a tent. They'll do a whole bunch of science, collect a mountain of samples, hop into their return vehicle, and come on back to Earth. But it doesn't make sense. I talk about this a lot. It doesn't make sense to put all of your plans on hold because Elon Musk and SpaceX say that they're going to do a thing. It would be great if they pull it off. And it would be, I've mentioned time and time again that if and when SpaceX is able to deliver on the dream of the 2-stage fully reusable orbital rocket that can refuel in space and go to anywhere in the solar system for a fraction of the price of any launch vehicle in the existing market, then our brains can't comprehend how that changes humanity's future in space. But Falcon Heavy took 10 years to build when they didn't think it was going to take them that long. So it could very well be that if you're just going to wait and just put your plans on hold, waiting for Elon Musk to sort it out. I don't think that makes sense either. So I think making a sample return mission that could just tell you definitively, oh, there's life on Mars, makes a ton of sense. So I wouldn't wait. But at the same time, you will learn a ton of lessons by producing your fuel locally on Mars, by launching from the surface, from collecting samples that will pave the way for future humans going to Mars in either the traditional way or in the SpaceX way. Tony Principi. Hey Fraser, what is the significance of finding intermediate-sized black holes other than checking the box to say we found them? Well, I think checking the box to say we found them is good. But no, we see stellar mass black holes, ones with, say, 10 times the mass of the sun. And we know that those are formed through supernova explosions. And then we also see black holes with millions, billions of times the mass of the sun. And how did the big ones form? How did you go from 10 times the mass of the sun to a billion times the mass of the sun? You would anticipate that there would be a collection of black holes of every size in between. And you would be watching with your gravitational wave experiments as these various masses of black holes are merging together to form the big monster black holes. But so far, almost every attempt to find an intermediate mass black hole has failed. They haven't been able to find them. There's been some hints that there are some lurking inside globular clusters. There was a really recent paper that just came out a couple of days ago where somebody saw an intermediate mass black hole through the lensing, the gravitational lensing of a gamma ray burst, which is kind of amazing, but like a total trick shot in terms of a science observation. And so understanding how we got supermassive black holes, they boggle the imagination, and yet we just have no idea why they are so massive so early on in the universe. And being able to see these intermediate mass black holes coming together would tell us a ton about how this process works. Margot Robinson. What's the case against colonization of Mars at this point? Adam Stelzner thinks we shouldn't. Yeah, I'm in the I don't think it makes sense to colonize Mars at this point. I think people watching this channel are fairly familiar with my position on this, but if you're not, I'll just give you a quick rundown. Mars is the worst. It's awful. It's terrible. It's a terrible place. There's no air to breathe. There's no water. There's no life. There's no trees, forests, oceans. There's just volcanic rock and volcanic rock that's been ground into powder. There is a little bit of carbon dioxide and a lot of cosmic rays. It's not on Earth, which is great, but anyone who goes to live on Mars is going to have just the hardest experience ever. It's going to be brutal. That every moment with our terrible low technology is going to be just a struggle for survival nonstop. And we've seen this played out many, many times here on Earth. People go to some place that is hostile to human life, like the coast of Antarctica, and they try to live because it's free and they've got their own space and They can look at penguins whenever they want, but they have to give up because it's fun in the beginning, and then it's just pain. It's just pain and it's pain. And so we have a base in Antarctica, which is permanently habitated by various nations who send scientists who are doing experiments, who are doing research in Antarctica. And they go because it's their job, and they're supported by an enormous amount of technology. And yet Antarctica, the South Pole, is infinitely more habitable than Mars. Like, it's just hard to wrap your mind around how bad it is for Mars. Furthermore, there is low gravity on Mars, and we don't know what the long-term repercussions are of that on the human body. Might be that it's fine. It might be that it softens your bones and it causes all kinds of health issues over decades, not to mention the radiation. And so the way we solve that is with an enormous amount of technology, with technology sent from Earth. And so there will be a time in the future when our technology is fantastic, when it trivializes our existence on Mars and it makes it really easy for us to live there. But until then, it makes the most sense to just send scientists, astronauts, people who are going to go to Mars, help answer scientific questions, help us learn to live in space, and help move us towards this idea of trivializing our future in space. But it's one of these things that if you go too early and try to live there, then all you end up with is just a lot of dead colonists. So I think that it makes sense to go there when it's easy, when it's comfortable, when we can support people living in those places. I think there's other issues as well, but whether or not, if there's life on Mars, then we have some other ethical issues that we have to deal with. But assuming that Mars is just a rock, that it's dead, then that's the thing that we have to worry about. Is just like, what are we doing to human beings who are going to go to this place? And they think it's going to be fun, but it's not going to be fun. It might be fun in the beginning, and I'm sure there's going to be a lineup of people around the block who would love to go and live on Mars. But I think that give them a year on Mars where all they do is just try to desperately survive, and they'll pine for Earth again, where you can just walk outside and breathe, and there's water, and there's trees and birds. So that's my thinking. Is it's just I don't feel like there's any value to sending a lot of people on to Mars. I mean, I know the argument is that we need a place that isn't Earth, so that we can have humanity be in two different places. But I think we're not ready to do that. I think that we can't escape our problems. We can't run. We can't set up a bunch of people on Mars and hope that that will give us any kind of long-term solution compared to what's happening here on Earth. So, 100 years from now, 200 years from now, I think there will be human beings in some form, or human robot hybrids or robots, across the solar system, living in giant O'Neill cylinders and amazing space cities across, there will be 1 trillion people living across the solar system. But that will come after we have matured the technology first. And we're not there yet, in my opinion. So I'm not sure exactly what Adam feels, but that's sort of my perspective on it. Raphael Dominichini, what's your favorite space mission already launched and the worst that you think should never have happened? So I'm going to do the worst that should never have happened, and it's going to be a really controversial answer. I think the one that should never have happened is the space shuttle. And I can't even believe I'm saying that. The space shuttle is the most incredible machine that humanity has ever made. It is a wonder of engineering, and everybody who worked on it should be absolutely proud of what they accomplished, from the engines to the fuel tanks to the boosters, everything. It's a stunning accomplishment, but it never should have been built, and it never should have never should have flied. We saw, it was inherently given too many competing goals from day one. And so it couldn't fulfill on everything that it was supposed to do, which is tough. It was supposed to be able to be a space truck, but it could never be that. It's a space truck that's on top of a bomb. So it's just so dangerous. And we saw, it took the lives of 14 people. Very much safer ways of flying to space had been figured out and was in the process of being perfected. You know, you haven't seen that kind of danger with the Soyuz or with any of the previous rockets. And you can see that NASA has gone back to Crew Dragon, the Boeing Starliner, using Soyuz flights. Like, it's a safe, tried and true way that fulfills all of your requirements for getting human beings to space. And then separately, there's a way to take cargo to space. So the space shuttle should never have happened. Never should have been built. It was a mistake. A beautiful, wonderful, astonishing, incredible achievement, but it was a mistake. My favorite mission that already launched, I would say right now my favorite mission is Gaia. And that's the astrometry mission from the European Space Agency, because I'm a huge fan of Swiss Army knives of spacecraft. And Gaia feels like the most useful tool that's been launched. I mean, astronomers use it to find stars. They've been able to use it to find other stars that perhaps formed with the sun. They were able to find white dwarfs and neutron stars and the motions of various dwarf galaxies that are being absorbed by the Milky Way. Like, it just goes on and on. I'm a gigantic fan of surveys. And that's sort of like why I'm so excited about the Vera Rubin. I love that you can just take a really powerful computer, bolt it onto the side of your telescope or satellite, and just crunch data and discover things about the universe. It's maximum observation, minimum theory. And I'm a huge fan of the experimenters, the observationalists, and giving them the tools to be able to do their job. So yeah, I would say Gaia is the one that I'm most excited about in terms of just astronomy. Mitch Harpino, when a star goes supernova that is massive enough to become a black hole, does that black hole come into being immediately after the star's collapse? Yeah, when a star, like a star with much more mass than the sun, is becoming a supernova, you get layers and layers of various elements that are forming inside the star. When you get iron in the middle, it's no longer generating an excess amount of energy through the fusion process. It's the equivalent of ash. And so the fusion process just halts the center of the star, and the star collapses in on itself because it no longer is able to be pushing out with light pressure. And so the star collapses, and it happens very quickly. And at a certain point, parts of the star are coming inward at like 70% the speed of light. So it is coming in fast. And it's like this, it just collapses all into this one point. And the supernova that we see is essentially all the additional material that couldn't go into the black hole fast enough, bouncing off the black hole and going out into space. And so you've got a black hole right there and then. And the supernova is just, you sort of imagine like when you have a bathtub and you let out the water in the bathtub and you get all the water in your bathtub doesn't immediately go down the drain. It swirls around because there's only so much room to go down the drain. And same thing, a black hole can only consume the star that it was once before so quickly. And if it can, it sort of gets too full, and then that's how you get the bounce material. But in some cases, it looks like now supernova just entirely form into a black hole, that it is able to stay on top of it and just gobble up the entire star and turn it into the black hole. But it happens right then. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to everyone watching here and on Twitch and everyone who asked a question. If you want to ask a question for an upcoming show, you can post it in the comments or on Patreon. You can join me live on my YouTube channel every Monday at 5 p.m. Pacific time. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.